Hey guys, how you doing? All right, this week in my class, we've been talking about converting fractions to decimals. So I thought now would be a good time to get an example out there so that we had it as a reference point. So I thought we'd start with something easy, like 3/8. If we're gonna have 3/8, and I'm looking at it and I'm saying 3/8, okay. Well, the first thing I know is that I always tell my students that fractions are really just division problems. And if you read it that way, it's a little simpler to understand. For example, 3/8 actually is 3 divided by 8, which is going to come into play later when you get into 6th grade, pre-algebra, and start doing some more algebraic equations. So what I'm going to do is I'm going to write that as 3 divided by 8. Now what do? Normal division. I'm going to look at here and I'm going to say 8 into 3. 8 doesn't go into 3 at all. I'll put a 0 up top. 0 times 8 is 0. I'll subtract. And I'm left with that 3. But I'm left with that 3 again. Well, what else do I know? I know that right after the ones place is always a decimal point. And after that decimal point, if there's nothing listed, there's an infinite number of zeros for the place values that come after that. The tenths, the hundredths, the thousandths. So I'll take my decimal place here, and I'll record it up there as well. What I do now is I'm going to take one of those infinite zeros that I know is there, and I'm going to drop it down. Right there. Now I got 8 into 30. Well, I know my 8 times tables, and I know 8 times 3 is 24. So I know 3/8 can actually fit in to 30, which gives us 24. Take a minute here, and I'm going to go. I'll do my subtraction. 2, that's a 10, and I've got a 6. Well, now I'm going to go, and I'm going to take another one of those infinite zeros. I'm going to bring it down. Now I've got 60. Now I know here that 8 goes into 60 7 times because 7 times 8 is 56. Take this, I'll subtract it. Again, do my regrouping. Got a 4. Take another one of those zeros. Bring it down. 8 goes into 40 5 times. Put my 5 up top. 5 times 8 is 40. I subtract it. Boom, done. I got 0. I don't need to bring down anything else. I look back up here, and now I know that 3/8 is equal to 375 thousandths. Wow, not so bad, right? Good. Now, let's take a look at another one. We had that. Pretty simple. What do you do when you come across something like 2/3? Well, this should definitely be interesting. 2/3. Well, I'm going to do 2 divided by 3. I know 3 goes into 2 0 times. I'll put a 0 up top. 0 times 3 is 0. Subtract. I'm still left with that 2. Well, I'm going to make that decimal point appear. And I'm going to start using those infinite zeros. Bring down my first 0. I know 3 goes into 20 6 times. 6 times 3 is 18. I'll subtract. There you go. Do some regrouping. I got a 2. I've got a 0. And it's coming down. I'm like, wait a minute. This looks familiar. So let me see how it plays out. 3 goes into 20 6 times. 6 times 3 is 18. Again, do some regrouping, and I'm at, wait a minute. Got another 2. I've noticed there's a pattern developing here. And if this happens, I'm well aware that this is going to be an infinite number of 6s that are going to come up. So instead of continuing, now that I've noticed that there's a pattern, I'm simply going to go draw the sign over the 6 and the 6 to denote that it repeats infinitely, and I could say that 2/3 is equal to about 66 hundredths. I could also say 667 thousandths, but I'm going to stick with 66 hundredths for the time being. One of the most important things you're going to really need to know to be able to do this is basic standard division rules using the algorithm, as well as your multiplication tables. Having a good understanding of your multiplication tables is probably the key. One of the most important things you can know going forward in math, especially once we hit 5th grade. You're going to need it for everything. We're going to need it when we're talking about finding equivalent fractions, fractions to decimals, decimals to fractions. We're going to be talking about a lot of those concepts. So, anyway, hope you found this helpful, and we will talk again.